Now we're going to talk about factoring by grouping. So factoring by grouping really has a lot to do with GCF, taking out the greatest common factor. So we're going to practice that for a minute. On these examples, for number 1, we have 2 times 3 and 4 times 3. So we want to know what they have in common. So they both have a 3. So we're going to take that out front. And then we are left with a 2 and a 4. Right? We can do the same thing with number 2. Look at what they have in common. We're going to bring it out front and write what we are left with, L plus W. If you notice, that is your perimeter formula. Number 3, we look at what they have in common, X and X. So we bring that out front and we're left with 4 plus 5. On number 4, we look at what they have in common, and they both have x squared plus 1. So we're going to bring x squared plus 1 out front, and then write what we have left, a 2 and a 3. So number 5, a little bit longer, we see what they have in common. They both have 3x minus 2. So we bring that out front. And we put what they have left, which is a 5x plus 4 and a plus 3. But these are the steps we're going to use when we're solving by grouping. So our first step, we're going to group our polynomial. We should have 4 terms. We're going to group the first 2 and group the second 2. And then we're going to find a GCF for each group. So if we look at the first pair, 10n to the third plus 16n squared. And so we see that they're both even. So we could take a 2 out of both of these. And so we'd end up with 5n cubed and 8n squared. But we can also take out a number of n's. Okay, since the first one has n to the third and the second one has n squared, the most we can take out is n squared. So we're going to take 2n squared, and when we do that, we're left with just 5n. This term had 3, we took away 2, so now it only has 1. Right, and this one had 2, we took away 2, so now it does not have any n, so it's just 5n plus 8. Right, so if we look at our second group doesn't have anything in common. So the only thing we can divide 5 and 8 by is 1. So I have 1 times 5n plus 8. And I'll just bring that down. And so now, at this point, you should have something in common between the two groups. So on this one, we can see we have a 5n plus 8 on both of them. So that's what we're going to take out front. That's what they have in common. And then in the next parentheses, we're going to write what is left. So we have a 2n squared and a plus 1. Right, so let's try number 7. We're going to group them. And so we're going to take out our GCF of the first group. So we can take a 5 from both terms, and we can also take out 2 x's. So 5x squared. And then in parentheses, we write what is left. So 5 divided by 5 will just give us 1. And we'll only have 1x left. So 1x. We had a 3. We took away 2, so it only has 1. And then minus, we had 25. And we divided that by 5, so we're left with 5. And we took away both of the x's. So now we'll do the second group. So both of those can be divided by 3. When we divide it by 3, we end up with x minus 5. And remember, at this point, you should have something in common. So that thing that's in common is going to come out front, x minus 5. Then everything that's left is going to go in parentheses, 5x squared plus 3. Right, so number 8, we're going to group our polynomial. So between 14 and 6, we can take out a 2. And we can also take out an x squared. So we're left with 7x minus 3. So we divided 14 by 2 and got 7. We had 3 minus 2, and we have 1 exponent. Over here, we took 6 divided by 2 and got 3. We had x squared. We took away x squared, so now we have no x's. So in our second group, we look at 49 and 21, and 7 goes into both of those. So 49 divided by 7, it's going to be 7x. 21 divided by 7, we're going to get minus 3. So these have something in common. So we're going to bring that out front. And what is left goes in parentheses.